I would like to discuss about the error detection codes, error detection codes in computer organization subject. We know that the computer consisting of many number of parts or many number of circuits. When the data is transferred from one component to another component, it is subject to change. That is, for example, I am sending from component C1 to component C2 one data simply 101. Due to the some any problems or by the external noise, the data reached to at C2 is suppose 110. You can observe that I am actually sending this one and it will be changed as 110. That is, this 0 changed as 1, this 1 changed as 0. So, the wrong values or error data cause at the receiver side or at the component 2 to for wrong calculations. Hence, we are going to be find out what are the data is changed during the transmission, or that means errors are happen, or the data is intact, not going to be changed. Suppose the data is changed during the during the transmission. To check the errors, to find out the errors, we are using error detection codes, right? One of the error detection code we are using is a parity bit. One of the error detection code we are using a parity bit. The parity bit is an extra bit to add to the binary information to make total number of ones within the information either even number or odd number. Remember carefully, the parity bit is an extra bit to add to binary information to make total number of ones either even or odd. Hence, the parity is going to be divided into two types. One is the even parity and another one is the odd parity. So, what do you mean by the even parity? Suppose after adding the one extra bit, the total number of ones in the information is even number, then it is called the even parity. Suppose, what do you mean by the odd parity? After adding one bit of information to the one bit to the total binary information, the total number of ones is odd number, then it is the odd parity. For example, let us consider I am going to be 11011. This is the information or data. Suppose this is the even parity and this is the odd parity. Generally, the parity bit is represented by the letter P. So, already the total number of ones are 1, 2, 3, 4 in this information. So, I am going to be add one extra bit. Its value is 0. Suppose this is the even parity. Suppose this may be the odd parity. To make the total number of ones, I am going to be add 1. Now the information is 11011 and 1. This 1 is the extra parity bit. In the same way, suppose even parity 11 1 0 11 0. This is total number of ones in the given information is even. Generally, in when we are using the parity, we always try to use the odd parity. Why? Because suppose when we are going to be transfer the information or data which consisting of all zeros, let us consider I am going to be transfer, this is the data. Now the even parity is again 0, but we observe that there is no ones in the entire information. There is no a single one is there. Hence, we are unable to set or determine there is a even number of ones. So, we are always prefer the odd parity. Right? Now, to the and one more issue is the parity can able to detect the errors, but it is unable to correct the errors. And one more issue is even the parity will able to identify the odd number of changes within the information, not a even number of changes. For example, let us consider the data is 11 0 11 plus we are adding one parity bit, odd parity bit, that is 1. So now the data is 11 0 11. Let us consider the data is transferred from component 1 to component 2. Right? Now here the total number of ones is 5. So there is any change in one bit, that is 11 0 11 and 11 0 11 101. So the total number of ones is even. So the error is identified. Again, let us consider 11 0 11 and I am going to be say that actually 11 0 1, this bit is changed 0 and this bit also changed 0. Now the total number of ones in the receiving an information is odd, that is 3. So we are unable to identify the error because we required 11 0 11 is the original data including the parity bit. Hence, we conclude that parity can only identify odd number of bit changes within the information. And now we are designing a parity generator and checker to identify the error. So parity generator and checker is a hardware circuit designed with the help of the exclusive OR gates. Its symbol is like that, right? To identify the bit errors in the data. So this so the parity generator is added to the sender side information. Here we are going to be add parity generator to the circuit. Right now, after generating the appropriate parity, the information is transferred to the destination or receiver. Here parity checker is there, then it will check is there any bit changes within the information or not or not. So in this way we are going to identify the errors. Now the design of the parity generator and a checker is like that. Please observe carefully. Now I am going to be consider the circuit has three transmission lines like that. Now I am going to be right. I am going to be connect these two to an exclusive OR gate. Right. This one. The output of the exclusive OR gate is again connected to the one more exclusive OR gate. Right. Please keep this one. Again, I am going to be connect these two lines to an exclusive OR gate, right? And I am going to be connect the third line to the output of the first exclusive OR gate. This is the exclusive OR gate. These two outputs of exclusive OR gates are again connected to an exclusive exclusive OR gate. Please observe that the circuit consisting of 5 exclusive OR gates. For example, we bifurcate the circuit like this in two parts. The left side part work as a parity generator and the right side part is work as a parity checker. So a single circuit consisting of both parity generator and checker. I hope you can understand this concept. Thank you.